Hello everybody, welcome to our new screencast, and today we're going to be having a look at GraphQL and getting started with Elixir and GraphQL together. The topic is fairly new to me, but I think it's good to record a screencast as a notes, and that's what we're going to do. Right, so I'm Hubert, I'm from AmberBit, and we mostly do Ruby on Rails. We used to do Ruby on Rails. Now we're mostly doing Elixir, and we're looking into GraphQL and using that more in our projects. So that's today's topic. I prepared for you on our AmberBit GitHub account an example application that we're gonna use to demonstrate the power and getting started with GraphQL. So first thing I'm going to do is to clone the repository. Git at github.com AmberBit, and this is workouts git. Alright, I just need to clone this. Here we go. This is our application. I will just check out one of the previous commits because I made some progress, and that's what we're gonna replicate here. So the idea for the application that we're gonna build is simple API that will allow you to search and fetch a list of workouts and training plans. So in my case, I'm interested into some full body workouts, but also maybe I'm interested in leg workouts. And I just want to query those and see the list of sets, which are like our exercises and repeats. And well, we're gonna focus on building API for that using GraphQL. So what we have now is two Elixir applications. I split up the GraphQL part to an API, which at the very moment is just a simple Phoenix application, scaffolded. Sorry, this is mix.exs. So if you have a look at this, this is basically just a Phoenix application, scaffolded. There's nothing added, and we're gonna focus on adding that now. In its router, it has just a standard page controller, and I think we can start it up. We just need to fetch the depths, and that should be working. Just a few seconds. Let's compile all the dependencies. Here we go, and we can go to my development machine, which is on Paron 4000. Yep, precisely. This is the page we expected to see. All right, let's stop it. As you can see here in the router, there's nothing else, just the default page controller. We're gonna change that in a second. And have a look at our core application, which is already prepared. I like to split up those apps the way that there's some business logic in the core, there's some API logic in the Phoenix application, so that's precisely what we're gonna do here. And this is just a simple Elixir project here. I added one file here, which defines so there's no ecto here yet, it's just a static API that has one function called all. So I get module workouts, it has an all function that returns me all of the workouts I have in the database. So for example, I have a day one leg day, which is the workout I actually did yesterday, and it sort of hurts today. As you can see, I did some barbell squats, then some more barbell squats, and again barbell squats. So I did 3 sets of barbell squats, 8 repetitions each. If you're doing some workouts and tracking that, reps is usually used instead of full name repetitions. And then I did some stiff leg deadlift, which is variation of deadlift with some more reps, and then I did some barbell calf rise, so that doing that I ensured my legs are properly hurting throughout from the bottom to the top, and I can hardly walk today. So that's good. That's what you want to do. Just for the sake of showing you how it works, I will add my today's workout, which is going to be day 2, and I think I'm gonna do chest. That's probably a good choice here for the chest workout after legs. And yeah, so today I will start with some exercises. So first, it's gonna be 10. So my exercise ID 10, name, that's 1, 2, 3, so I had some errors here. That's 1, that's 2. Let's just simulate it so it looks like it was fetched from database. So it looks like Ecto thing. And today I'm gonna do mostly push-ups and bench presses. So I'll start with some push-ups, and I will just do, how much can I do? Let's say I can do 30 in the first set. Then I'm gonna be doing some 35, which is probably my max, and I'm gonna do later I'm gonna do 30 again, and all I want to do later is bench press. So I'm gonna do bench press with some low number of reps, something like that, after I'm sufficiently warmed up. And this is set exercise 4, this is exercise 5, 5, 5, and this is core set 10, 11, 12, 13, 14, 15. Here we go. This is the plan for today. There's probably going to be some more exercises, but that's not important at the moment. So I can just start my console, and it doesn't compile because I made some error. Workout, this core workout, and what I have here, expected struct name, but the compiled was right of 35, so there's an error here. Here we go. So that's gonna be, here we go. Oh no, I'm just gonna fix that manually. Exercise. Alright, that should compile and compiles correctly. So my API, I can do all workouts, and that should return me all of the workouts I have in the database. My full database of workouts at the moment consists of day 1 legs, and this is my yesterday's workout, and my today's workout is chest. So that's what we're gonna do today. Right, so I get the what exercises I can do and how many reps and in which order. That's all defined, and that's cool. The other thing I wanted to do in my API is to be able to search for workouts. So let's quickly add that functionality. Have it open, sorry. Here we go. So in addition to being able to see all workouts, I want to be able to search by name of my workout. So for example, I want to search for leg workouts. I will enter legs, and that find my workouts. So by name it's going to be query, and I will just start with all, and then enum has filter select, I never know, I think it's filter, and there's gonna be filter with a name, something like string contains some fragment of name. Alright, just to demonstrate that thing, and let's see. So I can still get my all workouts, but I can also get by name, for example, legs. Here we go. That's my legs workout. Can I do chest? Yes, I can do chest. Can I do abs? No, because we haven't defined anything for abs just yet. Alright, so that's basically the API I want to expose today through the GraphQL. And we're gonna start doing that by first of all we need to specify dependencies between our applications, because at the moment if I start a mix server here in the API, I have no core available. Those modules are not available. So let's fix that and ensure that this works. So I can do core, and this is located in path above. I'm not using an umbrella app here, it's just two separate applications, and one is dependency of another. Let's see whether that... oh, I messed up. And check dependencies. Alright, I have to run this, even though it's just next to it. And I start it. Ooh, no. What did I do? What did I do? Ah, sorry. Yeah, I messed up. Here we go. That's better. That should start. Now my core workouts is available as an API from the API application. Let's add our dependencies in form of Absinthe, which is Elixir's library. I think there are some Erlang libraries as well you can use, but for Elixir, the Absinthe is probably the most mature one that exists. Right, so we need to add it to mix.exs file. Here we go, let's specify that. And I believe there are two things we need to add here. This is the Absinthe library. This current version is 1.4.9. You have to check what is the version you want to be using when you are watching this video. Absinthe plug in the same version. So I think the first one provides like the overall architecture for the Absinthe, and the second one is plug integration, which provides the plug which we're gonna use to actually forward those requests to Absinthe library. And we need to fetch those deps. What did I do? I'm not sure, the versions are probably not right. Mix deps get, that should be better. Anyway, that's the way you should do it. And now we can mount our Absinthe into the router. But before we do, we need to define schema, and we'll start with defining our types. So I am going to create lib schema directory where I'm going to put in my types. Right, in the module that will correspond to the path, no, not that precisely, this is API, schema, and then we got types. And we have to use this macro, which includes the DSL Absinthe provides to define the schema, define what resources and of what types we have. So our root resource is workout. So this is like Monday's workout legs, and or Tuesday's workout chest, and or Wednesday workout arms, and stuff like that. In the Absinthe, so if we go to the Absinthe, there's a getting started guide, and there's our first query, which we can have a look here. So this is how the Absinthe queries look like. We're gonna have a look at that in a second. Those are GraphQL queries, not the Absinthe queries. And this is precisely what they do here as a first step. They define their types in a slightly different manner because they use context. I'm not using context here. Right, this object is a part of the DSL and then fields. So they define posts and fields. Our example is going to be a bit more comprehensive because we are going to define some nested structure. So we have an object, and this is going to be object workout, and we're going to have some fields. First thing is the ID, and GraphQL specifications defines that type ID, which is basically a string. So there's a little gotcha here. In our Ecto or in our models, we are using integers. They're going to be serialized to strings. I think this is because they can be different sorts of IDs, like UID, and just to avoid defining different types, they decided this is like whatever that's unique and serializes to a string. And here we go, name. So our workout has a name, because let's have a look at our workouts. Oops, here we go. So our workout, this is ID name and the list of sets, right? So we have an ID name, which is a string, and sets, as you can see here, these are sets. This is a list of sets. All right. Now, here's a question of what is the list of sets. We are going to define it as a custom type. So if we just had one set per workout, which maybe makes sense, we would just do it like that. So this is field set, is of type set, and then we would define set that has some ID, and sets of ID, and there's field reps integer. So if we had like one workout that has one set, just one exercise you're doing with some repetitions, that would be it. But we are actually having a list of those, and Absinthe comes with these macro list of, which allows it to define an array/list depending on whether you're looking at it from JavaScript or Elixir point of view. So this is going to be a list of sets, and our set is defined here. So as we can see, set has an ID, reps, but it also has an exercise. So we need to have that field as well. And this is going to be a field and exercise of type exercise. Here we go. And we need to define that exercise as well. Exercise 2, ID, and it has a name. And I think it only has a name, right? Yes, because this is like name of the exercise that I'm doing today. And name, and this is string. All right, here we go. We defined our types in our schema. So we have workout that has many sets, and the sets has like number of reps of given exercise. So this is pretty standard relational schema, and maybe it makes sense for such an application. Alright, after we did that, we also need to define schema of the GraphQL schema that we are going to use, because those are just the types. We're going to import it into schema, and the schema is the definition of our API. Here we go. So we create a schema module, API schema, that will define our API. Absinthe schema, and we need to import types here. Import types, API schema types. Here we go. And for now, that's it. We will use that for now. To expose our API, which now is empty, we need to hook into router. So we need to find the router file, and probably makes sense to clean it up from all of these standard stuff. And we will just have an API, no prefix here, and I'm going to pipe it through API so that it accepts only JSON, which is something that GraphQL kindly understands. And we need to do two things here. We can do two things here. So as a first thing, we need to forward everything from the /API to Absinthe plug. And we need to pass it a schema that this plug will understand. So this says, please mount this Absinthe plug, which is our second dependency we added to our project, to use this schema definition from here at /API. So whenever we go to API with our HTTP requests, they will end up in the schema, in the plug that handles the schema. So we don't have like /API, /workout, /one, etc. It's more of a RPC style of doing those APIs. It's not a RESTful API. It's going to be all sent through POST to /API, and there will be some params sent over together to handle it. And the other thing we want to mount just for our development pleasure is GraphiQL, something called GraphiQL. So this is like a query maker /debugger, and we also gave it a schema. API schema. So GraphiQL is going to be the tool, the visual tool we use to make requests before we start using JavaScript, just to verify that they're working properly, etc. And I think that's correct, except this should be that. Let's see whether that actually runs. It's probably some compilation error. I'm a bad typer, but let's see. And yeah, it shouts at me for some reason. Compilation error, invalid schema. The root query must be implementation of an object. Right, I think our schema is not complete. Yes, it's not complete because I only defined the types. I haven't defined the any queries, and that apparently is a no-no here. So we need to add a query here to the schema. And if we follow these guidelines over here, we will end up with something very similar to what they did in the example. Alright, so we need to do query, and so give it some description. Get all of the workouts. It's gonna have one root field, which is gonna be workouts, which is a list of workouts. And we need to pass it a resolver. So that's another concept. So far we defined only the schema. So what types we have, and now we're defining what queries are allowed. So this is just a workouts query allowed, but we need to provide the way to fetch the stuff from database and or from somewhere. In our case, we're fetching that stuff from the other core application, so we need to provide it a resolver. API resolvers. Let's name it workouts, and there's going to be all with 3 parameters arity function, and we need to create that thing. So I'm just gonna make lib resolvers, and there's workouts ex API resolvers workouts, and here we go. And this resolver, we said it's accepting 3 parameters, and we're not going to focus on those 3 parameters yet. We're going to focus on them in a second, but for now we're just going to define the all function that takes 3 arguments and just ignores them. And it needs to return, in case of success, if we don't have any errors, we return a standard tuple with OK and the response that's going to be serialized. So in our case, this is core workouts all. So we are using the core application and the interface it provides to fetch the data. And this data is going to be serialized and sent back to client. Let's have a look whether that even compiles. It doesn't. Did you mean resolver? This is pretty Elixir giving me hints. Resolve. Yep, here we go. And now workouts is not defined in your schema. Workouts is not defined in your schema. Types must exist if referenced. So I did another error somewhere here. So it complains probably because my field, my query is a field name is workouts, and it's a list of workout, right? So I did it's not a list of workouts because that would be circular dependency. It's a list of workout. This is the type I want to have here in the list. Let's start it. Oh, it compiled. That's super awesome. Now we removed everything here, but we mounted this API GraphiQL thing, and this doesn't load. This doesn't load because I started the application wrong. So I just need to start the server first, and yeah, here we go. So as you can see, this is This is this user interface. This is the place on the left where you put in the query, and this is where you, on the right you're gonna see the result. And you can like bookmark many queries here. There's some export, import, and or whatnot. You can add headers, and that's pretty handy tool from what I gather. Let's have a look at how you can do queries. So in that case, in their documentation, they say we do query posts, a title and body. Let's try that. We don't have posts, we have workouts, and workouts have name. So let's try to fetch all of the workouts from our database. Here we go. So what do we have here? We have data returned as JSON, and there's a root element, workouts. It's a list of workouts. As you can see, I only requested the name of it, and that's the only field that got serialized. I could have requested the ID, and you can see I have the ID. What if I wanted to fetch all of the sets? I can do in workout. So ID, name, and sets. Let's see. Ooh. Cannot query field sets on type workouts. Did you mean sets? I did mean sets. So how do you query those associations? Is said somewhere here in the examples. I think in the next example. Query arguments that we're gonna need as well in a second. You can see here, this is how you query association. So you just name it, and you have to specify what do you want from that association, which we haven't done here. So I want some sets, and the set has reps and an exercise, and the exercise has a name. So this is the info I want to fetch, and this is not working for some reason. Sets, reps, exercise, name, which should be working, and it's not working because I might have some issue here in my schema definition. Workouts, schema types. Whoops, I have it open somewhere, but let's just ID. So workout has sets. I wanted to do sets, which I didn't do. So workout. As you can see, this schema is directly mapped to my query. So I could say set here and it would start working, but it doesn't make sense. So that's a list of sets, not a single set. So naming matters in that case. Let's restart the server, and this is something that is going to work now. So I have data, workouts, sets. So workouts has sets, but it also should have an ID and a name because I requested. Does it have? Yes, it has. So it was returned in the wrong order, but it was returned. I think JSON has undefined order, so that's fine. Day one legs, an ID. And then we got sets. So sets number of reps of 30 push-ups. So that's what is ahead of me today. 30 push-ups, 35 push-ups, 30 push-ups, and then some bench presses to finish it up. Okay, that looks good. What else can we do with GraphQL? In this screencast, we can do some search. For example, if I wanted to search to get only the leg days exercises, I can have some API with some query parameters to facilitate that. And how you do it in GraphQL is that you have to specify the argument here in your query or /n in the schema, depending on whether you're querying like a children of the root scope or on the root scope. Right. So in our case, we added this function by name, I think, to our core. So we have our argument also, let's call it by name, and it's going to be string. Alright, so that's why we did here. We can add the parameters here in this way, I believe. Name is going to be lex. Let's see what it does. An error, unknown argument name on field workouts. Sorry, because I added it as a by name. So by name. Alright, that returns me workouts, but it's still not the filtered list. That's the full list. In order to get the filtered list, I need to pass this this thing to the all, and this is handled by the Absinthe itself. So I don't have to handle passing those arguments to resolvers manually. They're going to be passed automatically. So let's open our resolver, and this is where those arguments are going to come in handy. So let's define another clause of the function all. The first argument is parent, which is not something we're going to need here, but the second argument are the arguments. So this is usually called args, and the third argument is the resolution, which has a bunch of stuff inside, which might become in handy, but not for this query. So in our case, we want to catch all those queries that have argument by name and with some query, and forward it to different function of our core module workouts. So I think I defined by name. So we have all, and then we have by name. Right. So we have all and by name. Yeah, that sounds fine. Let's see whether that works. And lex. Ooh, we got an error. Core workouts by name is undefined /0 because I haven't passed any arguments, and indeed that function doesn't exist. So I need to pass it an argument. Here we go, data workout set, and this is my leg day. Oh yes, it hurts only after looking at it, so I can feel my legs just by looking at it. But let's see whether we have chest day as well. Oh, that sounds fine. We got our bench presses and stuff. Do we have arms day? No, there's no arms. Do we have abs? No, we don't have. So we built our first APIs that can actually do something. They query our database of workouts, they return some data, and you can find that if you go to github.com amberbit/workouts, github.com/amberbit/workouts, you are going to find exactly that code we just run. So just check out the fifth. I might want to tag it with something that's screencast one step or something like that later, but the fifth commit from the bottom is the full source code I just prepared for you, and you can follow me and just do the same. The guide is quite nice for the starting. It's definitely a good starting point. There's also more in details, in-depth book by authors of the Absinthe library on the Pragmatic Programmers, which is like $25, and I think it's very much worth the money. So just go there, spend your dollars, and learn some GraphQL. And I think that's it for now. We're 40 minutes into screencast, and see you next time.